I'm seeing that there is a lot of assumptions made, and there's a lot of issues that happen in areas that aren't shown on drawings.
Pro Clima inspires and educates people to create healthy, durable, and energy-efficient buildings to live, learn, work, and play in. Welcome to the Pro Clima Podcast. In this week's episode, we speak with Peter Raimondo. Peter hails from Toronto, Canada, and is a senior building enclosure engineer at Oculus Building Science and Facades. He shares with us some of his experiences in moving from designing buildings for survival to incorporating indoor-outdoor flow. Welcome, Peter. It's a real pleasure to have you with me here on the podcast today.
Thanks for having me in the lovely Pro Clima office down in Penrose. I'm looking at the big house behind you, and it's always fun to be here.
What do you think of our new little house?
The new little house? This one over here?
Yeah.
Oh, I actually didn't get a chance to go inside or look around at it. I literally did not notice until you pointed it out right now. I was just in the zone, coming in, getting situated and stuff like that. Had a meeting too. So yeah, I'll go have a look afterwards. Apologies for not noticing it before.
Not at all. Peter, I was just interested to know, you grew up in Canada. Tell us a little bit about what life was like growing up in Canada.
Well, I grew up in Canada, but Canada is a big place. A lot of the people that I meet here in New Zealand from Canada are kind of from like the West Coast, like Vancouver area. I'm from Toronto. I'm from like downtown Canada, the big city, the Auckland of Canada, I guess. But yeah, in the winter, it goes down to minus 40 sometimes. I think recently they got about a meter of snow in like 2 days. And at that point, there's nowhere to put the snow because there's just so much of it in the downtown city. But yeah, in the summer, it also goes up to 35 degrees. It's very super humid in the summer. In the winter, it's very dry, which is opposite of what it is here in Auckland. So yeah, what was it like growing up? I grew up on a farm. My parents are tomato farmers. So I grew up driving tractors. I grew up being outside most days. And then after work, wanting to go home into an air-conditioned house and cool down after being in the 35-degree heat and, take a shower and clean all the dirt off and stuff like that. But yeah, growing up in Canada, you grow up inside. I'm not sure if I'm describing this right, but we have an expectation that the inside is going to be comfortable at a certain temperature and that the inside is generally going to be separated from the outside. Because it gets so cold in the winter and because it gets so hot in the summer, everything's kind of climate controlled. Whereas coming here to New Zealand, indoor-outdoor flow really kind of just is the thing. It took me a little while to get used to that, but at this point, I like it. I usually leave my windows open and my doors open and stuff like that to get the breeze through. But yeah, a little bit different.
What excited you about going into engineering as a field of study?
I kind of fell into it, if I'm honest with you. When I was a kid, I would be building a lot of Lego, and I like to figure out how things come apart and go back together, how all the parts work. I'd be driving a tractor and want to know how every single lever works and where it all connects to and stuff like that. So I guess that's how my brain always worked. And then when I was in high school, someone suggested, hey, why don't you go into engineering? And I looked into it and I'm like, yeah, that sounds pretty good. My two choices were either civil engineering or mechanical engineering. Civil engineering was what worked out. And then how did I get into actually building science engineering? Fell into it. I worked on a construction site using like a total station doing surveying stuff. And yeah, I got comfortable on a construction site. That was during school. And then after school, worked for a construction company and then didn't really like that job because it was a very toxic work environment, got laid off, went to Europe for 5 months, came back, worked as an a cappella singer, worked as a barista. And then eventually some guy came into the coffee shop and had an engineering shirt on. And I said, oh, hey, engineering, are you looking to hire? And he's like, I don't know, maybe. And then sent him a resume. And then I started working in forensic engineering, which is basically investigating buildings that either had big leaks or had burnt down, and how to fix them and how to avoid that problem again. And then from that, got into building science because they're kind of very closely related. And one of my friends was quitting his job to go back to school. And he said, hey, do you want to interview for my job to replace me? And then, yeah, started working at a company called RJC, Reed Jones Christopherson in Toronto, and was hanging off the sides of buildings on ropes, like rappelling, poking at sealant, spraying water at things to try to find leaks and condensation issues. And yeah, it all kind of just felt right. It all kind of just fell into place. I'm not sure how to describe it other than that. It just kind of worked out and I just kind of went with it because it made sense.
And then, what was it, 7 years ago you moved to New Zealand?
About that, yeah. About 7 years ago, 2018, November, December.
What was the thought about moving to New Zealand? What excited you about this beautiful country that we live in?
I don't want to give you the exact same answer, but I didn't really think about it very much. I'm hopefully not to scare any of your listeners. I kind of go off vibes, and it just seemed like the right choice. I had gotten a little bit bored and burnt out at my job in Toronto because it was, day in, day out, kind of the same thing over and over, and I wasn't getting paid very well. So I decided that I wanted to go somewhere. And I think 5 years previous, I had signed up for an email list from New Zealand Immigration to send me job offers. And then slowly but surely, I guess, subliminally advertised to myself that I should go to New Zealand. And then once I decided I wanted to quit my job, found a very cheap flight to Melbourne and then found another cheap flight to Auckland and showed up with a backpack and a dream. And everything kind of worked out. I'm not sure how it all worked out, but yeah, everything kind of just fell into place and I've been here ever since.
So you mentioned that you moved from a country where you had this real divide between the inside and the outside, and you were really comfortable inside, and outside you had these massive, from minus 40 to almost plus 40. I mean, that's crazy change. Yeah. And now you've landed in a country where it's all about, as you mentioned, indoor-outdoor flow. What was it that sort of surprised or shocked you about some of the things that are going on with construction in New Zealand compared to what you're used to?
It was definitely a learning curve coming here because, like you said, I was used to climate controlled, the inside being inside, the outside being outside. And coming here, not really knowing what to expect because I didn't really do any research at all before coming here, to be completely honest with you. I'm being very transparent right now. Yeah, I didn't really know what to expect. I didn't even realize there was a leaky building crisis. I didn't realize that indoor-outdoor flow was a thing. I didn't even look at the temperatures and humidities. I just hoped for the best and showed up. But once I got here, I think the first thing I noticed was that everybody's windows were open in their house because I got here basically at the beginning of summer or like late spring. Everyone had their windows open, but there were no bug screens. And then I said, why aren't there any bug screens? And people were like, oh, there's no bugs here. But then I was getting bitten by bugs. And I'm like, what do you mean? Where do you get this from? So there was that, people hanging all of their laundry inside or outside in the backyard. And then it rains and it gets wet again. And then you have to bring it back inside. And so all these little things that I just never did because in Canada, we would always have, a washer and a dryer. You dry inside. Yeah. Coming and seeing the building, seeing lots of nogs in the walls, that was confusing to me because I had been around a lot of timber buildings in Canada because we build with a lot of timber in Canada, but only with vertical studs, not really very many horizontal studs at all. Like you put them if you have to hang something on the wall, if there's something to connect to, a handle, something like that, but it wasn't a standard. It wasn't ubiquitous. So that was another one. Metal roofs with just an underlay and a mesh below them. That's not a thing in Canada, or at least not in Toronto where I'm from and not the buildings that I was building. So yeah, just like different ways of building things. And at the time, it was very confusing and surprising. But since being here for 7 years, I get it. I understand. I see the context now. I see how the ecosystem of construction has, come together here in New Zealand. And also the fact that supply chains are a big, big, big thing that affects a lot of stuff here in New Zealand because we're kind of down here in the bottom of the Pacific Ocean. There's been times where I've specified something that was available in market, and then 2 weeks later it was no longer available anymore because someone had decided to pull their company out of the country. And it's like, oh, okay. So I understand why people distrust new companies because they've been burned before by that company leaving after selling them something. So yeah, little bits and bobs, I guess I've figured out, learned about, and I guess gotten comfortable with.
So tell us a little bit more about the nogs and why nogs are used here versus not being used over in Canada.
The reason they're used here is because they were used here, and so they continue to be used here. That's the only real reason that I can justify. The answers that I've gotten, the reasonings that I've gotten, the justifications that I've gotten are that the studs, when you put weight on them, they try to bend outwards, and that structurally I understand. That's how studs work. If you have them, in this direction, they will try to buckle longitudinally. But once you put a board on the inside and a board on the outside, you're holding those studs. And so therefore, they're not moving side to side or buckling anymore. But I do understand that people, because Radiata pine gets used here. It's not the strongest, most durable timber. So that's another reason why people might use them. I think it's really just tradition. Just that's how it's always been. Because even when I speak to structural engineers and I explain, hey, this is just an infill wall. There's no gravity load on these. There's no chance of buckling. Can we get rid of the nogs? They still give me that look like, oh, really? Do we have to? Because it's just, that's not how people do it. And so like, I understand that. It's been ingrained for so long that it's scary to try to change that because there might be unintended consequences. And given the context of New Zealand, there have been consequences for people removing something or people, saying, oh, we don't need that thing. She'll be right. And then it's not right. So like, I get that. Nogs, I still feel very strongly about because in the building code, it specifically says that you're allowed to have it. As long as you have the boards on each side, you don't need the nogs. But yeah, I'm not sure if you have any more insight into why they might still be used, but it seems like it's more just tradition and just the feeling that they should be there. And it is weird to not have them there. But whenever I suggest it in a meeting or on site, all the carpenters are like, oh my God, really? Amazing. No problem. That's so much less work. It's so much cheaper. But yeah, I usually have to convince everybody else on site to make sure that that's okay because I don't want to just unilaterally say, don't put any nogs and then scare people.
Talking about terms and things talked about in the building industry, New Zealand, you hear a lot about this term, we need breathable homes or breathable buildings. Mm-hmm. What's that all about? What is breathable and should we be doing it? Shouldn't we be doing it?
We should be making them breathable, but it depends on what your definition of breathable is. If breathable to you means all the air goes out everywhere, that's not what you should be doing. It should be, like we mentioned before, that I'm used to being in Canada where everything's climate controlled. And so if you're in a house that you want to be climate controlled, a temperature inside that is different than the temperature outside, if you have air just escaping everywhere and kind of uncontrolled going wherever, first of all, you'll spend a lot more money on heating and cooling to keep that interior temperature, that temperature. But also there could be unintended consequences because if you have just air leaking out into your roof, into your walls, through your windows, here, there, and everywhere, it could carry, first of all, energy, but a lot of water. And so that moisture that's in that air goes into a certain space, gets to a cold surface, let's say, turns into condensation, and then you have a condensation problem somewhere that you can't see it because it's inside the wall, inside the roof, somewhere hidden. So breathable in terms of being vapor permeable is a good thing. So if there's water inside your walls for whatever reason, it will dry out to the exterior or dry out to the interior, depending on which makes sense, which kind of heating climate, cooling climate you're in. But having just uncontrolled air just blasting through everywhere, that's bad. You don't want to have that because it's not good for energy efficiency. It's not good for comfort. It's not good for the durability of your building. So if you think about a building like your body, you don't want air coming out through like the side of your rib, through your arm, through your hand, through your foot. You want it to come in and out through your mouth. And so that's what you should be doing in a building as well. You should have a breathable, but when we say breathable, we mean vapor permeable building, and then have a proper ventilation system somewhere so that the air is going in and out from the place that you want it to go in and out because that's where it's supposed to go.
Now, Peter, you talk a lot about sealing things up.
Sure.
In New Zealand, you get a lot of people saying they don't want to feel as if they in a plastic box or a glass bowl or whatever. They want to have this indoor-outdoor flow.
Sure. I've heard that people don't want to live inside a robot before. And I'm like, inside a robot? What kind of building are you living in? Is this like a movable kind of dancing building or something? But yeah, no, I've heard all kinds of things. Yeah, a lot of people are scared by the sealing up because they want things to be breathable. I've even heard certain very scientific bodies or companies in New Zealand talk about how, yeah, you want to have your underlay under your cladding to have gaps in it and not be taped shut because you want wind to blow through and dry out the walls. And I'm like, oh my gosh, no, don't do that. First of all, you should be designing the walls so that the water doesn't build up inside them. That's the first thing. If you need help with that, you let me know. Give me a call. But in addition to that, like I mentioned before with the breathability and the ventilation part, you want the air to go where you want it to go. And it shouldn't be just uncontrolled going and blowing through your insulation. It shouldn't be going through gaps here and there. It should be going through a vent. It should be going through a ventilation system, or it should be going through your open windows, open doors, the places where you're choosing the air to go through. It shouldn't just be all over the place. So yeah, it's a story or a journey that you have to take people along sometimes. And you have to kind of understand the context of where they grew up, what they're used to, what they think is comfortable. Some people believe that they want to sleep in, 12-degree temperature rooms. I personally like a nice 20 degrees, but 12, sure, that's fine. But you have to kind of explain that if you want it to be 12 degrees, but you have uncontrolled air, then it could be 15 degrees. It could be 5 degrees. It could be any number of degrees. And if you're not controlling where the air goes and keeping the inside in, the outside out, and then controlling that ventilation, then you don't have that control over the temperature. And you're kind of just at the whims of weather, at the whims of nature, and just hoping for the best. So, yeah, it's good for health, I think, to have the inside temperature be a certain temperature and a certain relative humidity. It controls mold, controls drafts, controls comfort. It increases the durability of your building because, like I said, uncontrolled air carries moisture with it, could cause condensation problems somewhere, and then maybe you have to go replace your roof prematurely for no reason. I feel like I kind of went on a little bit of ramble there and I've lost my train of thought, but did that answer the question?
Totally. No, Peter, you feel free to ramble. I really enjoy
You'll just cut these together, hopefully. Oh. It's like usable things. Yeah, hopefully.
So now we've talked a lot about sealing up, and obviously there's ways and means of testing how well you've sealed the building up. Sure. And I think you must have mentioned somewhere, I don't know where I found it, but that the blower door is one of your best friends. And I think you mentioned as well that you would love to give a blower door to every single builder.
Yeah.
What would a builder learn from that? What do you think would be the main thing that they would pick up if they started playing around with the blower door?
First of all, did I say that? I mean, it sounds like something I would say, but I'm not sure. And I have best friends that I now have to go negotiate with, like, oh my gosh, I'm friends with a fan now. But I guess, it's good to have a big fan. But anyways. So, sorry, what was the question again? The question was,
what would they learn if he was using a blower door?
I've done this on site before. And so I've had buildings that have been completed. The windows are in, the seals are on, the cladding's on, the roof is on, etc. And then I say to the contractor, hey, what if we do a blower door test? And they say, what's a blower door test? And I say, well, you open the door, you put this thing in there, there's a big fan, there's a computer, you're testing the pressure inside, pressure outside. Basically, what you're doing is checking the airtightness generally of the building envelope by depressurizing or pressurizing. And they say, okay, well, are we going to fail? And I'm like, no, this is just for research. This is just for understanding. This is just so that you guys see what's going on. And so we bring the fan to site, we put it in the door, we pressurize, we depressurize. And then I go around with them and I say, okay, look, do you feel this over here? Do you feel that over here? And they feel a draft coming in and you can see the cogs working. You can see them like, oh, there's that thing that I forgot to tape up. There's that other thing that sealant hole that I forgot to fix. That's where that wind is coming. And so they basically, just by depressurizing and feeling the wind, even if you're not using like a smoke pen to show the air coming in, you can still definitely feel it. And yeah, from that, they learn which parts of the envelope need a little bit more attention, which parts are easily missed, which parts maybe they need to do a little bit more QA, a little bit more quality assurance for their subbies, let's say, because you're trusting your window installers to install the window properly. But how do you check that? And so once you bring them out and you show them, hey, air's coming in here, air's coming in there, air's coming in there, you really see them start to understand and start to plan and start to think about future projects or even past projects that they've done. Sometimes they worry. They're like, oh my gosh, we never did this before. Is every building that I've ever done bad? And it's like, no, it's like every other building that hasn't been tested with a blower door. But now that you know this information, you can use that on next projects and do much better.
So Peter, we've been talking about a lot of change away from what this industry is used to.
When you say we've been, like today or just
today.
In general? Have we talked about, okay, sure. Sorry, I'm just, I'm trying to follow along here. We're talking about changes. Because to me, this doesn't sound like a change. This is just what I do every day. So to me, it doesn't feel like a change. It's the only reason I ask. But
we're talking about change from what traditionally architects, builders, and building owners
and the building code is used to.
The building code.
Yeah, or at least the acceptable solutions.
Exactly. So we're talking about things that are different. Now, I'm interested to know from your experience in the last 5-6 years that you've spent here, who is the most difficult of those three to introduce these ideas to? Would it be the architect, the builder, or the building owner? And For what reason, and how do you think we could try and convince them better?
I love the question, but I'm going to give you an answer that is not one of the options that you gave me. I would say someone who believes they know. That's the problem. If you believe you know something, that's usually very difficult for me to convince you of something. If you know, and when I say no, I mean like underline capital letters no in bold, and you don't have any doubt about anything and you don't rethink about your beliefs, those types of people are the ones that are very hard to convince because they believe that everything that they've built before is good. Everything that they've spent money on before is good. Everything that they've designed on paper is good because no one has come back to them to complain about it. Because in New Zealand, I'd say, I don't want to discourage anyone. I don't want to say anything bad, but there is a lower expectation for buildings here. In Canada, or at least in Toronto, where I'm from, because it goes down to -40 in the winter, if there's a problem with your building, you are going to notice immediately within that first year because it goes down to -40, air starts leaking through somewhere unintended, and then you get a gigantic block of ice inside your wall. You know? And so like I've inspected these before. There was this big hotel that had concrete walls and the sealant, the air seals between the concrete panels had a hole in it. And then there was this gigantic iceberg on the outside of the building over like traffic that they had to close off the street because ice was falling down from this. And it was because the warm, moist air from the inside was going outside and turning into ice. So when I say that here there's like a lesser expectation, it's because it doesn't get super hot and it doesn't get super cold. So like the problems very slowly show up. It takes 10 years for a condensation issue to really show up and start to like come through the ceiling or come through the walls. So with those kinds of situations, someone might build hundreds of buildings, never have a complaint because no one is really expecting anything better because that's just how most of the buildings, exist. They are good for about 15 years and then maybe they kind of get a little bit, kind of musty, a little bit kind of moist smelling, but that's just how an old building is, whereas in Canada, that kind of situation would be a very large problem immediately and then it needs to get fixed. Whereas here, it's kind of fine. So back to the original question. Who's the most difficult to convince? It's just people who don't have an open mind to hearing that there's other ways to build, that there might be different unintended consequences that they might not have heard of, that there might be long-term consequences that no one has ever called them before because they don't believe it's something that can be fixed. So it can be an architect, it can be a builder, it can be a developer. I've had all three that are very good to work with and really want to listen, really want to learn, and really want to try to do better. But I've also had ones that literally do not want to hear anything about it. And I just say, okay, here are the risks. If you don't like it, that's fine. Call me in 10 years and I'll fix the problem.
So talking about what's actually going wrong. So you're going out onto sites where issues have happened. What are you seeing out there?
I'm seeing that there is a lot of assumptions made and there's a lot of issues that happen in areas that aren't shown on drawings. Because you have a full drawing package for a building, let's say, and you'll have most of the details that you'll see on that building. But then there's one little corner, one little roof interaction with a wall, one window that's kind of different than the rest. And the installers just have to kind of make it up on site. And I don't blame them, because they're just doing their best. They're doing whatever they did on another building and trying to apply it here. And a lot of times I'll find that that's an issue. There's also the issue of potentially someone not seeing how something could eventually turn into a problem because, the building code, the acceptable solutions show that it has to be built like this. They build it like that. And if they build it like that, it should be fine. And that's how it should be. That's how the building code really should be. But there's a few little bits and bobs in the building code, in the acceptable solutions that eventually could turn into a problem, or on a very specific project with a very specific, set of interactions between different building envelope components that would turn into a problem eventually. So yeah, it's really these unintended consequences, these situations where someone doesn't know what they don't know. Because you can't know what you don't know unless you know what you don't know. I'm saying a lot of things all in a row, but it's like that Dunning-Kruger curve where at the beginning you start learning about things and you're like, wow, I know everything. But then you learn more and you're like, uh-oh, I don't know anything about this. And then eventually you get back up to knowing a good amount about things. But yeah, I'd say That's probably the biggest issue. There's things in the building code that people build every day that are part of the acceptable solutions that leave a little bit to be desired. And if you have too many of those little bits and bobs all together, it could turn into a very big problem. That's probably the biggest one.
Now, obviously, with all these proposed better ways of doing things, there's always a cost associated with it.
Sure, of course.
How do we manage that trade-off between extra cost versus doing things better?
So I'd say the first conversation that I try to have about a topic like that is kind of setting expectations for how wide we're looking at this problem. And so if I use this membrane versus this membrane, one membrane is much more expensive than the other one. If you're just looking solely at membrane versus membrane, hypothetically, I'm saying this because I'm in the Pro Clima studio and I'm looking at the Pro Clima membranes outside. There's times where one thing costs a lot more and that's all someone looks at. But if you start to look at the context in which it's being placed and all of the smaller little bits and bobs that you can delete or problems that it will fix or durability, redundancy, those kinds of things that extend the lifetime of the building, then it starts to work out. So like one example, and I'm not going to use a Pro Clima example, I'm going to use roofing. You guys do roofing, but I'm talking about different types of membranes in your roofs. But there's like one type of membrane that is you get a big kind of kettle and you melt the asphalt inside that kettle and you're mopping it onto site.
Yes, I know.
So you know which one I'm talking about. There's multiple that are on offer here in New Zealand. But with that, sometimes I'll suggest that for like, let's say a building podium where you have a podium shared between two big buildings or something like that. I'll suggest that. But in the meeting, I'm already saying, guys, this membrane is about twice the price of any other membrane you've ever used before. But by using this membrane, you can have no falls at all. You can delete all the screed. You can do this. You can do that. You can put a green roof on top of it. You can put a paver on top of it. You can ballast on top of it. You can put insulation. You can not put insulation. You can do whatever you want. It just gives you that flexibility. And once you kind of look at all the knock-on effects from that, it might be the exact same price as trying to build a sloped roof, put a membrane on top of it, put a metal roof or whatever, like that traditional way. So yeah, if you kind of think outside the box and start from the beginning of a project, right at the beginning of design, to try to do things a little bit better, but take advantage of the benefits of that thing that you're doing. I feel like I'm not describing this very well, but I'm going to keep going. This one product might be more expensive, but because of all the unintended or extra benefits, it could end up being cheaper and better, more robust, more durable than anything else. So yeah, what I try to do is I try to open up the box and try to understand where they're putting the boundaries and try to change those boundaries. So it could be, like I said, thinking about the unintended or the extra benefits from that thing, but it could also be the lifetime of that building. Because if this one thing is so much more durable than the other traditional way that you were building, maybe you get another 50 years of life out of that roof, as opposed to just 15 years of life and then having to replace it. So if you start looking at the full lifetime of the building and how much less maintenance you might have to do, then it starts to become more cost effective. So I love working with clients that have long-term assets. So like government clients are always great because they own their schools, they own the hospitals, they own, all the different things. But then there's also, clients that are build to rent or private institutions of whatever sort. Those ones are my favorite clients because they want to know about those extra durable ways to build and kind of thinking a little bit outside the box of what traditionally is built. So I hope that answers the question.
Totally.
Cool.
So going back a bit, Peter, obviously we're all in the industry now and a lot of people have got, they've learned a lot over the time. But how do we change the education of our future architects and builders so that they're able to more easily consider these better ways of doing things?
That's a very good question that I'm trying to work on. I also spoke to one of my peers in the industry, Stein from Babbage. Shout out to Stein. He's great. And yeah, he and I are speaking about having an industry group amongst us. First of all, building science, building envelope, facade engineers, whatever you want to call us. A lot of people have different words for it. So starting an industry group so that we can all start to work together and kind of think about different ways that we can, I guess, converge on the ways that we build Because if we're all converging on something and saying, this is probably the best way to build something, or these 3 ways are the best ways to build something, then people can kind of follow along and they can see that there is some sort of leadership, some sort of coherence, some sort of, working together. So that's, I'd say, one good place to start. Another good place to start is my recommendation for everyone working in this industry to go overseas. Go travel somewhere, go to Europe, go to North America, go to Japan, go to Southeast Asia. Like go literally anywhere around the world and just start looking. Just look at how things are built. And especially if you can find buildings that are still under construction, so you can see how the wall's being built, just see the different context, see the different ways that places are built, see how places are built in a very hot climate versus a very cold climate, externally insulated, internally insulated, where the vapor barriers are, where they're not, et cetera, et cetera. So that's another good place to go. I would love the opportunity to do more speaking at universities. I've done some universities, speaking to them, just speaking to architecture students and construction engineering students about what I do and what kind of things I look at and what types of ways I try to improve a building envelope. But I think really just asking more questions and being more curious and doubting yourself. Doubt yourself as much as you possibly can. I speak very confidently. I doubt myself all the time. I'm always checking in. Did I understand that properly? Am I missing something? Is there a different way to build this? Am I not understanding something that my client's asking me? I'm always trying to understand first and then making a decision after I understand the context. Like I said, if you believe you know the exact perfect way to build something and you never check that, there's a very good chance that there's a blind spot. Very good chance that you're missing something.
Now, Peter, you are the MC of the upcoming Building Science Summit.
Indeed.
Tell me a little bit about that.
This is our 2nd year. We did one last year at about the same time, beginning of March, and it seems like we're probably going to do this annually. It has a good momentum. Everyone seems to enjoy it. But really, it's just an opportunity to speak more about the technicalities of the building enclosure, the building envelope, the things that separate the inside from the outside. Because here in New Zealand, I don't know if you've done any research here, but it's kind of hard to find a lot of New Zealand-based info, New Zealand-based research. I know Brands has a lot of really good research. They spend millions of dollars a year on research, and you can go look at that. But I find that there's less guidance documents that come out of that. A lot of the ones from Brands are for traditional ways to build things. They're great at that. If you need some advice on how to build things traditionally, go to Brands. They have a lot of stuff on their website. But I think for this conference, we're trying to bring a little bit more international flavor, bring a little bit more of, hey, have you ever seen this before? This is what they're doing overseas. What do you think? Because me coming here to New Zealand, I still wanted to go to conferences, but I would generally fly out of the country. I'd go to Europe. So I went to Italy for a big building physics conference. I went to Melbourne for a couple of building physics conferences as well. Building physics is what building science is called in Europe. Generally, there's a lot of different terms for what we do. But what we're trying to do is just bring international speakers in to give just a little bit more variety to what you can hear and listen to and learn from here in New Zealand. And trying to have like a big open discussion. We're going to have lots of questions and answers. I'm going to be there. All the other speakers are going to be there. You can ask us all questions. If you have some random thing that's going on in your building, you can ask that. And yeah, just trying to bring together a group of like-minded suppliers as well, because we do have a lot of supplier sponsors. Myself, Stein, Brian from RDH in Canada, Hartwig from Europe. I'm not sure where he works. Is he just
Germany?
He's from Germany. Cool.
Yep,
but which company? Is he just by himself? He just does his own thing? Is he a
he's
professor?
Woofy. He's the founder of Woofy.
He's the founder of Woofy?
Yes, he's actually been on the podcast.
I should know this. I am so sorry. That's my bad. See, like I said, you always have to doubt yourself and you have to be open to learning things. I really should have known that. He is the guy who made Woofy. I use Woofy all the time. So once again, yeah, bringing experts from around the world to have conversations about these things, because I'm learning that the Woofy was invented by a guy who is actually coming to speak. And I could pick his brain about hygrothermal analysis and different things like that. So yeah, it's just good to have that in New Zealand, and it's good to have that open conversation because it's hard to find here. And like our Oculus, the company that I work for, we try to put out a lot of reference documents. You've seen, we've done some podcasting. We write like written guides and things like that and how-tos. So yeah, really trying to just build up a library of New Zealand-based knowledge and New Zealand-based guidance documents so that if the acceptable solutions of the building code, or if the documents from MB Brands or any of the, the traditional New Zealand research, or I'm trying to think of the right word here, bodies, whatever they put out, if you feel like there's something missing there and you just don't have that context, come talk to us. Like, we're just trying to flesh it out a little bit and give a little bit more international knowledge, because it's always good to spread knowledge.
Definitely. So we'll definitely put a link to your podcast in the notes of this podcast.
Love that.
So that people can go along there, have a look. You've got some awesome stuff.
We do our
best. And Sean have a real, I love the way you bounce off each other.
And forth.
It was funny. I was listening to one of your podcasts. You're talking to Sean about the olden days of smoking in restaurants.
Sure.
Remember that? Smoking on planes and restaurants. And the fact that then they built these little boxes where people go and all huddled together.
I remember that back in the day.
And then 5 years later, they were gone.
Yeah.
But you were talking something about how that it was quite interesting about, because the smoke could tell you a lot about how ventilation works and airtightness.
It was also interesting because those rooms had amazing ventilation. They had, not even in restaurants, in my university. When I first started at the University of Toronto, there was this big, student hangout area called the Pit, or the Atrium, had both those names. But basically, it was this basement area with a big kind of area where you can just like do stuff, hold events, whatever, and then a bunch of desks around. And if you went and looked around there was all these relics from the past. And one of the relics was, so there was the main kind of stage area and then 3 places with desks. And one of them had this big box on the ceiling. And there was this switch, and you would turn on the switch and then it would make like lightning, because I think it was short circuiting and stuff like that, because it was old from the 70s or the 60s or something like that. But what it was that side of this pit, of this student lounge, was a smoking area. And so you'd go in there, and I guess it was glassed off, and they had the ventilation system, and it was pulling, cubic meters upon cubic meters of air out and cleaning it. It might have been cleaning with a filter. I never actually pulled it apart. I don't know if it was exhausted to the exterior. It might have been. But yeah, these places in these little boxes, these little rooms inside these restaurants or in the student lounge that I was talking about, would be very good at ventilation, like probably the best ventilation in the whole building. But yeah, you could see how the smoke moves. You can see where it's coming out from. You can see the clean air coming in under a door. You'd get a visual look. So yeah, if hypothetically anyone's wondering about the airtightness of their building, just pick up smoking, smoke a pack of cigarettes inside your house, and you'll see all the smoke, and it'll like go here and there. I would recommend doing a blower door test instead, and maybe just feeling it, because, smoking's not great for you, but hey, it's an option, I guess. I'm not sure if that's where you want me to go with this, but.
Now, going to your own personal life, I hope you don't mind, but we were talking earlier about the fact that you bought a place. You bought your own apartment here in Auckland 2 years ago or something.
Yeah.
Now, tell us about how that's working out, what you've done to it, what you want to do to it.
I'll give you the context first. It's on K Road. If anyone knows about K Road, it is a loud place on a Friday and a Saturday night. And it's an apartment on the first floor, so not the ground floor, but just one above. I'm not facing onto K Road. I'm facing onto an alleyway or like a smaller road. But I get a lot of the noise from K Road. It's an apartment. It has some sloped skillion roofs, and there's clerestory windows above my kitchen area. And so those windows, when I first moved in, and I'll just give you the whole context, moved in, old aluminium, non-thermally broken, single glazed windows. All the gaskets were old and migrated and, shrinking and cracked and stuff like that. So not very airtight, watertight enough. There was no ventilation system. There was one heat pump in the main room up near the clerestory windows, which are like 3.5 meters up, maybe more, maybe like 4 meters, 4.2 meters. Anyways, up near the top. And so I moved in, and it was comfortable enough. I moved in at the end of summer and then into the winter, and it was comfortable enough, but I spent a bunch of money on my heat pump to keep it somewhat warm, because I like to keep my interior at a certain temperature. In the summer, I leave the windows wide open, but in the winter, I close everything shut and I leave my heat pump on a thermostat. Now, what I wanted to do was I wanted to improve it a little bit. So first thing, number one, was windows. I got rid of the old aluminum windows, the single glazing, the old gaskets, and I got UPVC, like European style windows. Shout out to Stark. Thank you for my windows. And shout out to Gary from WM Windows. He did my windows and they're great. But they're tilt and turn windows, UPVC, double glazed. They shut very tightly with good gaskets. So on a Friday and Saturday night, I can close all my windows and I don't hear anything outside. It's silent. Silent is a strong word. There's still, through the walls and stuff like that, but at least it's not coming through the windows. I still leave the heat pump on. I haven't changed that. That it might be the next step. I might go ducted heat pump, but haven't done that yet. I also got a ventilation system, like a heat recovery ventilation system. Shout out to Lech from Swagon. Just, call it everybody out. But yeah, got a ventilation system. Because I have those skillion roofs, there's this little attic space above my bathroom. And that's where I put the ventilation system. And that's where I ran all the ducting to bedroom, main room, bathroom. And yeah, that's what I've done. It's much more comfortable than it was. Friday and Saturday, I can close the windows and I don't have to worry about, opening the windows to vent anything out because the ventilation system is handling that. The ventilation system also has summer purge or what's the word I'm looking for? Bypass. Yeah. So during the summer when it's cooler outside than it is inside, it'll just ramp up to, not max capacity, but like 80% capacity and avoid the heat recovery unit. And so it just cycles the air and tries to keep things cool. And yeah, it works out pretty well. It's from the 90s. I could say that it's direct fix cladding because it is from the 90s and it is like, that stucco finish on the outside. Yeah. But I've done investigations and it's dry somehow. I guess good maintenance on the walls, but also I think there was like the fiber cement plus a fireproof gypsum board, seems like, because there was like multiple layers of gypsum board as opposed to just the fiber cement. So yeah, it's been pretty dry. The balconies, my balcony got replaced because I think they had membrane with direct fix tiles on that membrane. So eventually after 10, 15, 20 years, started to rot out the timber and that all had to get replaced. But yeah, all done now. And we're going through kind of a maintenance schedule of replacing everybody's balconies one by one because it costs a lot of money to do that, but you have to do it eventually. So yeah, that's my apartment. That's how it is.
Excellent. So just as we sort of come to an end now, Peter, just to summarize, we've talked about the importance of airtightness, of ventilation, of good quality windows, insulation, putting the insulation in the right place. So we've talked about education, where people can find these things. So we've talked about, obviously, you've got the Oculus website, you've got a whole lot of information, you've got podcasts, you've got
obsf.co.
We'll add that as a link. Cool. Obviously, Pro Clima, we've got a lot of resources.
Yeah, lots.
Are there any other areas? You've talked about people going overseas to go and see how people are building.
Yeah.
Are there any other things that you could just add on that people could do to try and educate themselves?
Yeah, if you're looking for things to read and look at, buildingscience.com. Just go to buildingscience.com. It's spelled exactly like you think it is. That is, I believe, Joe Stiebrick.
Joe Stiebrick, yep. He's one on the podcast as well.
He wasn't my professor, but I saw a few guest lectures from him. He's amazing to listen to. Very funny. But yeah, his website has literally anything that you could ever possibly want to know about building science. It's all there somehow. There's also Building Science Fight Club on Instagram if you're looking for more social media kind of scrollable stuff. And I believe that's his daughter that has taken all the buildingscience.com stuff and is slowly putting it onto social media. So that's pretty cool. The rdh.ca, I assume, is their website. Haven't gone on it in a little bit, but they have a lot of research freely available. And they've done some crazy stuff like figuring out how external insulation works and how to attach it to the building and attach the cladding with, no brackets. It's only with screws and battens. And so they've done the research on how to do that and they've tested it. They've also tested with external insulation and like taking off more and more cladding and just blasting it with water and showing that the insulation keeps the wall dry instead of absorbing water like you think that it does. Mm-hmm. Yeah, if you've never used external insulation, if you've never used Rockwool before, it does not perform the same way as like a fiberglass bat or a polyester bat. It is very, 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 very different. And yeah, if you want to know more about that, you can come ask me. You can come to the Oculus office. We'll show you we have a sample of Rockwool that's just been sitting in a pool of water for the past 7 years. You take it out, it dries out, and it's the same shape. It's not rotted. It's, fine. So yeah, where else can you find information? If you do like a passive house course, that'll give you a lot of the context around building science, around energy flows, around airtightness, thermal bridging, stuff like that. Therm and Flixo, if you're looking for different softwares to learn, that'll teach you how to do, thermal bridging analysis and isothermal kind of analysis. If you want to learn Woofy's another good one. I think you guys
run courses. Jesse runs from Australia.
Exactly.
Yep.
I've only done like the level 1 course, but I know enough to kind of know how it works. But yeah, to go like be a power user and know all the different intricacies of that software, you can do some more courses on that. So yeah, I'd say that's probably a good place to start, and then contact us if you want to know more.
Excellent. And of course, come along to Building Science Summit.
Of course. Definitely come to the Building Science Summit. That goes without saying. I thought that was, an obvious one, but yeah.
So tell them about the amazing venue we're having it at, Peter.
Ooh. So we're doing it in Christchurch, in Wellington, and in Auckland, but I'm most excited about Auckland.
Yeah,
because it's the new International Convention Center. Because like when I first got here, I saw the big cloud of smoke and we flew over it on the way to Melbourne for a conference. And now they're finally opening it. Or they opened it? Yeah. It's open?
It's open.
It's open now.
But very early days, yeah.
Yeah, I'm really excited to see what it looks like and kind of walk around and see how it's working because it's beautiful.
It is. Thank you very much, Peter.
You're very welcome. Thanks for having me.
Sharing knowledge is at the heart of our strategy to make buildings better for everyone. Sign up for our podcasts to learn more about creating healthy living conditions by protecting building structures from external and internal moisture damage. Thanks for listening. Looking forward to having you with us next time.